All right, so you know why you're here, right? You want to get past all the AI hype and understand what's really going on with these massive language models. And that's exactly what we're doing today, diving deep into a fascinating study from Tsinghua University. We'll be exploring how these models.
Oh, wait, someone wants to join. Hey, go for it.
Hey, thank you for having me. Can we quickly go through and review this paper with the key point and main takeaway? We just have about 5 minutes.
Hey there, so glad you could join us.
Absolutely, welcome.
Yeah, we could definitely do a quick rundown.
The core of the paper is investigating if these big AI models truly reason.
Or if they just memorize a ton of stuff.
Their key idea is misleading fine-tuning, or MisFT.
Messing with the rules to see what the AI really understands.
They fine-tune the models on math with wrong rules.
Like saying 4 plus 6 equals 12.
Then they test if the AI applies those wrong rules elsewhere.
It helps see if they actually learned the rule.
And their big takeaway is that LLMs show signs of real reasoning.
They can apply these weird rules to new situations.
It's not just rote learning, there seems to be abstraction.
Okay, let's unpack this MisFT idea a bit more.
What's fascinating here is how they tackled evaluation.
Because figuring out if an LLM is truly thinking is tough.
It's the problem of data contamination, you see.
Even clever tests might have similar stuff in training data.
Exactly. Did it learn the concept or just recall something similar?
Previous attempts used counterfactual tasks.
Hypothetical situations, but still hard to guarantee no overlap.
So how did this Tsinghua team get around that?
Their MisFT method changes the game entirely.
Instead of new questions, they changed the fundamental rules.
Yes, during a specific training phase.
Kind of like teaching someone that red means go.
And then seeing if they stop at a red light.
Right, you know their behavior isn't from previous knowledge.
Precisely. By using unlikely rules, they avoid that data issue.
So if the AI still performs, it's likely from this new training.
Much stronger evidence for actual learning and application.
Pretty clever stuff, right?
It really is.
So how exactly did they mislead these models?
They used number overloading as one key method.
Okay, let's unpack this. What is number overloading?
Essentially, they remap the meaning of numbers.
Like saying the symbol 1 now means the value 2.
Exactly, a consistent swap of numerical symbols and values.
So if they showed 1 plus 1 equal 2, it was learned differently.
Right, using notation for these remapped values.
And the models picked this up surprisingly fast.
LLMs with billions of parameters learn these new systems quickly.
It's wild how they can rewire those basic number understanding.
It truly is remarkable.
But was it just memorizing these new pairings?
That's the crucial question. So they used math word problems.
But using this new incorrect number system.
Problems the AI hadn't seen in the misleading training.
Can you give us a quick example?
Imagine a problem about adding apples, but 1 means 2.
So 1 apple plus 1 apple in the problem.
Dot refers to 2 actual apples plus 2 actual apples.
And the model, using the new rule, would give an answer.
Yes, an answer consistent with the misleading number mapping.
Meaning they understood the quantity despite the wrong symbols.
Exactly, suggesting abstraction beyond just symbol matching.
And bigger models did better at this, right?
Yes, larger models generalize these systems more effectively.
Points to scale, helping with abstract rule application.
It definitely seems that way.
They also mess with the math operations themselves.
Yes, that's an operator overloading, redefining addition, etc.
So the actual rules of arithmetic were changed.
Precisely, like a new plus that adds and then adds 1.
So 2 plus 3 becomes 6 with this new rule.
Exactly, and they explored more complex redefinitions too.
And again, LLMs could learn these totally new ways to calculate.
Yes, and the key was applying them to word problems.
Could they use the wrong addition rule in a story problem?
They could. If the story needed addition, they'd use the new rule.
Even though the math was wrong, they were consistent.
Supporting the idea of understanding the described relationships.
And larger models were better at this too.
Yes, they handled complex redefined operations better.
More evidence that bigger models aid abstract reasoning.
That's the trend the data suggests.
They even tested this on those vision language models.
Oh, this was a fascinating extension.
Models that understand both text and images.
They fine-tuned VLMs on text math with the misleading rules.
But the VLMs learned the wrong rules from text only.
Exactly. No images involved in that learning phase.
Then they tested them on visual math problems.
Problems where numbers and symbols were shown as images.
Could they apply the text-learned wrong rules to visual math?
Remarkably, yes. They generalized the rules to the visual domain.
Abstract reasoning across different ways of seeing information.
It really highlights a deeper understanding.
Different VLM designs showed some performance variation.
Yes, suggesting the architecture matters for this generalization.
How the model handles text and visuals together is important.
Absolutely.
And they tried to see which parts of the model were key.
By selectively freezing layers during the misleading training.
seeing which parts were needed to learn and apply the rules.
The deeper layers seemed crucial for applying the rules to new problems.
Like memorizing 2 plus 2 and 5 is shallow, but using it in stories is deep.
Precisely. The deeper layers seem vital for that abstraction.
So these findings really push the reasoning versus reciting debate.
This study strongly suggests more than just memorization.
Applying novel rule to new situations points to reasoning.
But those performance dips suggest memorization still plays a part.
So it's likely a mix of both going on.
A nuanced picture of learned associations and emerging reasoning.
And larger models generalizing better fits the emergent abilities idea?
Yes, complexity seems to unlock more sophisticated skills.
How does MisFT compare to older ways of testing AI?
It helps avoid biases from carefully crafted prompts in other methods.
Prompts might give unintentional hints.
Exactly. MisFT's training on weird rules gives a cleaner test.
A more rigorous way to see their actual understanding.
Precisely.
So the big takeaway for our listeners,
LLMs and VLMs show a real ability to learn and apply new rules.
suggesting genuine abstract reasoning capabilities.
And understanding this is key as AI becomes more important.
Helps us move past the black box of AI.
And this raises fascinating questions about intelligence itself.
Could AI develop totally new ways of understanding?
Important questions as we keep developing these technologies.
Definitely recommend checking out the original paper for more.
Understanding this helps us shape AI's future responsibly.
Thanks for joining us for this deep dive into AI reasoning.
It's been a fascinating exploration.
We hope you found it insightful and thought-provoking.
Join us next time for another look beneath the surface.